Welcome back to Deep Learning from Scratch. In part 1, we build a network that could only make guesses. Today, in part 2, we give it the power to learn. We will unwrap backpropagation, the elegant algorithm that taught machines to see, to read, and to think. Let us pull it apart in 3 dimensions. Here is the problem. A network performs a forward pass and produces a prediction. But the prediction is wrong. There is an error, a gap between what the network said and the true answer. The question is simple, yet profound. Out of all these thousands of weights, which ones are to blame, and by how much should we change each one? Backpropagation is the answer. Picture every possible setting of the weights as a point on a vast landscape. The height at each point is the loss, the size of the network's mistake. Training the network is a journey across this landscape, always stepping downhill toward the lowest valley. The slope under your feet is called the gradient, and it tells you exactly which direction is down. The mathematical key is the chain rule of calculus. If the loss depends on the output, and the output depends on a weighted sum, and the weighted sum depends on the weight, then the gradient with respect to the weight is just the product of these local derivatives. Backpropagation is the chain rule applied layer by layer from the output all the way back to the input. Watch what happens. The forward pass sends signals from the input toward the output. The backward pass does the opposite. Starting from a loss, gradients flow backward through every neuron, every connection, until each weight knows its share of the blame. This is why it is called backpropagation. Once we know each gradient, the update rule is beautifully simple. New weight equals old weight, minus the learning rate times the gradient. A small step downhill, repeated thousands of times, gradually walks the network into a region of low loss. Watch the loss curve fall as the network learns the end gate, from random nonsense to perfect accuracy. That is backpropagation. Forward pass to predict. Compute the loss. Backward pass to assign blame using the chain rule. Then a tiny step of gradient descent on every weight at once. In part 3, we move to real data, real loss functions, and the optimizers that power modern deep learning. If this clicked for you, like, subscribe, and we will see you next time.